So first step is to go over your questions on the homework assignment due today, which was assignment 9. So if you would please pull out assignment 9, which is on page.
Assignment 8.
I'm looking at assignment 8. Yes, sorry, I'm looking at the wrong day. So page 261, 262, assignment 8. Thank you. And what questions, what problems would you like to go over?
For all of the graphs, is it solid line and solid dot?
So for this one, because in this book, there's no inequalities, these are all solid, right? On what you did in class yesterday, those problems had some inequalities. So on the quiz tomorrow, you're gonna have one that's just an equation, solid graph. Second, then you get 2 that are inequalities, okay, to graph.
It's just me 3 questions.
Remember there's a front and back because there's 2 standards. So on the back standard, there's gonna be, and then there'll be a 4.0,
Yeah.
okay? I'll also ask you about domain and range on the graphing problems, okay? Yeah.
Can you go for number 30?
Number 30, okay, let's take a look at 30. So 30 lists for us this equation. It says D equals square root of H over 0.57. And the problem reads this way. It says the formula for calculating the distance to the horizon is given by this formula, where D is the distance to the horizon in miles, and H is the height above the surface in feet. Okay, so you might have, for instance, you might see a mountain or something like that. Okay, all right. So graph the function. And so we want to take a look at the graph of this, and then what is your height above the surface if you can see a distance of 5 miles to the horizon? So let me do the part B first, and then we'll do the graph. I'll pull up my graphing calculator for that. So part B says that the distance to the horizon is 5 miles. What is your height? So we're going to solve for H. So to do that, the first step is to, well, let's just put it equal to this. So we want to get rid of the square root first, so we're going to square both sides. So I guess I do need a calculator now. Put that up here. All right, so let's go ahead and square that. On this one, we're going to have to just have this is 25 equals H over 0.57. And now I've got to multiply 0.57 times that 25. So 25 times 0.57, and that gives us 14.25 equals H. Okay, and that would be on 30, that would be in feet. So that means that the person's probably standing on a little hill, they got their own height, or they're sitting down on the hill, whatever it might be. Where they're measuring from is 14.25 feet. All right, now let's take a look at the graph. Now this is just a reminder, you might have to change your window on graphs. Okay, that's something to be aware of. We're always on our standard window. Sometimes you gotta change the window. So we want a graph for part A over here. Now it's pretty obvious that if I put in 0 for height, you're gonna have square root of 0, so it's gonna be, it's not gonna give us anything. But let's go ahead and look at this. So y equals, let's do second square root and we're going to use the fraction x divided by 0.57. Okay, and let's say graph. So this is what a zoom, this would be what our standard graph would look like, right? And so if we look at that, it starts at 0, 0, and we're gonna get a couple values just to plot on there. Okay, negative values are an error because it's a square root. But then positive values. I will ask you to do a table tomorrow, okay, to just make sure you've got a good shape on it. So for this table, we're gonna start at 0, 0, and then let's just get a couple other values. 3 is at 2.3. Let's go out a little further. Let's go down to maybe 20. 20 is at 5.9. Now notice that you don't need a lot of values to give it the shape, but it starts slowing down how fast it goes with that. So in this first one, I'll go 0, 0, and then we'll do 5, 10, 15, and 20, and then 1, 2, 3, 4, 5, 6. All right, so 0, 0, 3 is at 2.3, and then 20 is, 2.3 is up here, sorry. So 2.3 is right about there. And then 20 is at 5.9. 2, 3, 4, 5.9. It's about there. Okay. Now, again, we probably don't have an infinite domain on this one, because if you think about it, the height of how high somebody can be is not going to be infinite. But that said, you know, we don't know what the limit is, so we just put an arrow to say it goes on somewhere. It's going to stop like at a mountaintop or something, the highest mountain, for instance. Okay.